Hey guys, this is Mrs. Elliott, and these are your Unit 5 Lesson 5.A notes on factoring quadratics. First, what is a quadratic expression? It is an algebraic expression with the highest degree of 2. What this looks like is x squared. Our degree is our exponent, and the highest degree is a 2. In standard form, a quadratic expression is written as ax squared plus bx plus c, where a, b, and c are all real numbers and a is not 0. If you had a quadratic expression and a was 0, you actually don't have a quadratic expression because there's really not a term there, and so the highest degree isn't 2 anymore, it's 1. These notes will mainly focus on factoring these quadratic expressions. And factoring is just the process of finding what to multiply together to get an expression. Back to the basics of what you probably remember as factoring is, say you have the number 10. I can factor that into 5 times 2. Those are the factors of 10. Now looking at this example, we have 2y plus 6. Well, both 2y and 6 have a common factor of 2. We see that 2y has a 2, and I guess I should use a highlighter here. So 2y has a 2, and 6 has a 2. So there's the 2 that's in 2y, sorry. Okay, so both of those have a 2. So we can actually factor the expression 2y plus 6 into 2 times the quantity y plus 6, okay? So you can say that 2y plus 6 has been factored into 2 and y plus 3. So it could kind of look like this. Erase that. You could do 2y plus 6, and then it's factored into 2 and y plus 3. Those are the two factors of 2y plus 6 because, in fact, if I multiply them by each other using the distributive property, I would get 2y plus 6, and it checks. So what we just did was we factored using a GCF. If you recall, a GCF is the greatest common factor. It is the largest factor that you can factor out of two different terms that they have in common. So let's try a few examples, and we won't be using whiteboards because I'm not there, but here we go. We're going to factor these expressions completely. There's two methods. There's the factor tree method. This method only works if you're working with the GCF. When we get down here, we're not always working with the GCF, so the factor tree method isn't always going to work once we pass this line right here. Sometimes it can, but it won't always. So factor tree method won't always work. I would write that down on your notes. Okay? All right, so factor tree method is basically breaking it down into all its factors. This breaks down into a 5 times x, and this breaks down into a 5 times 2 times x. Okay, those are all of the factors. Now I'm simply going to circle what they both have in common. So we have a 5 here and a 5 here. We have an x here and we have an x here. Okay? So the greatest common factor here is a 5x, and what was left over was an x, and then we connect it with the plus sign, since the plus sign's right there, plus 2. And so the expression 5x squared plus 10x actually factors into 5x times the quantity x plus 2. To check your work, just try to distribute and see if you can get back to your original answer. All right, so let's look at this U-try. We can break this down into, 2 times 2 times 3, and then we have 2 x's. And we can break this down into 3 times 3, and then we have an x. I'm not worried about the negative. I'm going to use it as my connector here in a minute. So we'll get there in just a second. So what they have in common is they both have a 3 in common, and they both have an x in common. So my greatest common factor is 3x, and what is left over? 2 times 2 back here is 4. We also had an x left over. Don't forget we had a subtraction sign connecting the two terms, and then we have a 3. Once again, if you want to see if it checks, try to distribute and see if you can get back to your original expression. Next, we have the box method, okay? The box method. Once again, this won't always work once we pass this line down here because we are working with the GCF right now. So I have two terms, so I'm going to draw two boxes, and I have negative 4x squared plus 24. So I put those in the two separate boxes, and I'm going to factor out the greatest common factor. Well, while one is negative and while one is positive here, okay, so you got one negative and one positive, and I just messed that up. We are going to go ahead and pull out the negative, okay? And then when we go to write our final answer, we're going to remember that a negative times a negative equals a positive. And we will consider that when we're trying to get back to our 24, okay? So what is the greatest common factor of 4 and 24? Well, knowing our multiplication facts, I know that is 4. And they both don't have an x, okay? Notice they both don't have an x, so I'm not going to factor out an x. So my greatest common factor is actually negative 4. So right here, right above the boxes, I'm just going to write out what I know I need to multiply by negative 4 to get me back to negative 4x squared. Well, what can you multiply by negative 4 to get negative 4x squared? X squared, okay? And then what can I multiply by negative 4 to get 24? Well, remember this over here, that a negative times a negative equals a positive, so I'm going to make sure I write negative 6. And over here, I'm going to write my answer, negative 4 times the quantity x squared minus 6. To check your work, make sure that you can distribute that negative 4 back, and you would get your original answer right there. All right, next, I draw my two boxes. I write 15x squared. I write 12x, and I'm going to put the greatest common factor right here. They both have an x, so I'm going to go ahead and write x. And 15 and 12 have a greatest common factor of 3. And so there's my GCF. And then now I'm going to ask myself, what can I multiply by 3x to get me back to 15x squared? Well, 3 times 5 is 15. And what times x would give you x squared? Well, x. X times x is x squared. Now I want to get back to 12x. What times 3 would give me 12? 4. And we don't need an x because we have 12x, and 3x times 4 would give me 12x. So I'm going to come over here, excuse me, and we have 3x times the quantity, 5x plus 4, and we could distribute and make sure we get back to our original answer, in which we do. All right, next, factoring trinomials. Factoring trinomials is a little different. We can factor a GCF out of two trinomials if it exists, okay? In the next few problems, we will see that it does not exist, and so we're not going to try to factor something out that's not there. You could factor a 1 out, but you could do that all day long. You continue to factor a 1 out, factor a 1 out, factor a 1 out. 1 is an identity. Remember, everything has a common factor of 1, so that doesn't really count. So here, just an example, we have a trinomial. And what is a trinomial? It is an expression with 3 terms, okay? And then we're going to factor it into 2 binomials. What is a binomial? An expression with 2 terms. So here we go. We have x squared plus 5x plus 6, and it can be factored into x plus 2, x plus 3. I literally could do that in like a half a second. Why? Because I know the trick and I've been using the trick for so long, and you will get good enough at the trick that you will be able to do it really fast as well. Well, how did I get 2 and 3 so fast? Well, I know the trick that if I do have a leading coefficient of 1 right here, in which I do, if I don't see a number, I know that number is 1. And since I see that number as 1 and I don't see an x here, there's no possible way there's a greatest common factor. They don't all have an x, and that guy is 1. So not going to worry about a GCF, but I do know the trick, and that is I'm looking for 2 numbers that'll multiply to give me 6. That will at the exact same time add to give me 5. And how do I know that works? Well, let's look at the method of FOIL. FOIL is when we multiply from left to right with distribution. So with a distributive property. So here we go. I'm going to multiply x times x, and I'm going to get x squared. Then I'm going to multiply x times 3, which is my outer 2 terms, and I'm going to get 3x. Then I'm going to multiply the inside 2 terms, and I'm going to get 2x. And I'm going to multiply the last 2 terms, and I'm going to get 6. And as you can see, I got that 6 from multiplying, And I ought these two for multiplying, but they will combine. And when they combine, I'm adding and I get 5x. So that's why the trick of finding two numbers that will add to give you that middle term, but multiply to give you that last term will work every time because of the method of FOIL. Okay, so once again, we are looking for two numbers that will add to give us our middle term and multiply to give us our last term. So here's how it's going to work. If you simply find the factors of your last term, you can quickly find the two numbers that add to give you the middle term. So what are the factors of 6? Okay, factors of 6 are 1 and 6 and 2 and 3. Well, which of those would actually add to give you that middle term of 7? Well, 1 and 6 will. So I'm going to write my answer as two binomials. I'm going to put an x here and an x here. Why? Because I'm looking for x squared, and x times x is x squared. Then I'm going to fill in my 1 and my 6. It doesn't matter if the 6 were here and the 1 were here, okay? It's still, you would multiply each by an x and add them together and get 7x. But it does, it checks. You have x times x is x squared. You have x times 6 would give you 6x. You have 1 times x would give you 1x. And guess what 6x plus 1x is, guys? Yes, it's 7x, which is what you wanted. And then finally, 1 times 6 would give you 6, which is what we wanted. So this is the factored answer right here, x plus 1 times x plus 6. Okay? Let's do some U-try problems. If you want to pause and just see how you can do on these without me, that's cool. If you want to keep watching, that's cool as well. So right quick, I want to find the factors of 12. Okay, the factors of 12, and that's 1 and 12, 2 and 6, 3 and 4. If you can't find those as quickly as I can, that's fine, just as long as you can figure them out. And I'm looking for a pair of those numbers that would actually add to give me 8. There they are. So my answer is x plus 2, x plus 6. Next, factors of 25. All right. And that is 1 and 25 and 5 and 5. Those are the factors of 25. I need a pair of those to add up to give me 10. There they are, 5 and 5. So that's actually x plus 5 and x plus 5. And that's how we write it every time. This one can actually be simplified because we do have what appears to be a perfect square. Perfect square is when a number is multiplied by itself. Well, this is x plus 5 times x plus 5. So I can just write it once and give it a little square right there. Okay? The above trinomial examples were all positive terms, so therefore we had all positive factors. So anytime you have an all positive problem, you have all positive answers. What if negative terms are involved? Okay, what if negative terms are involved? Well, if negative terms are involved, you're just going to have to pay a little more attention to what's going on and to what the factors are. First up, if you have a positive number at the end but a negative number at the middle, that means that you've had two negative numbers multiplied by each other that equal to positive, and when you add two negative numbers together, you actually get an even bigger negative number. So we will be looking for two negatives. So the factors of 9 could be -1 and -9, or -3 and -3. And which of those would add up to give us -6? Well, -3 and -3. So I'm going to go ahead and write my answer out. And once again, this is another perfect square, so I can just write it once and put a square on the outside. Next, we have -20. And this time, we have a negative right here and a negative right there. Okay, a little different. If you multiply two numbers by each other and you get a negative, that means one of them was negative and one of them was positive. So listing out the factors of -20, I'm going to have to list out, I'm going to have to switch the signs. So +1 and -20, or -1 and +20. +2 and 10, or -2 and 10. +4 and 5, or -4 and 5. And I'm looking for a pair of numbers that actually adds to give me -1. A lot of students usually struggle with this one. If you don't see the number, that means there's a 1 there, so that's a -1. So which of these pairs would add to give me -1? And I forgot to put the negative right there, and I forgot to put the negative right there. I was probably confusing you guys. Sorry for that. Which of those pairs would add to give us -1? Right here. 4 and negative 5. So positive 4 and a negative 5, and you're done. Next one, back to having a positive at the end. So that means they're both negative because they're going to add to give us a negative. So I've got negative 12 and negative 1. I've got negative 6 and negative 2. And I've got negative 3 and negative 4. Which of those will add to give us negative 13, negative 12, and negative 1? And here we go. Again, we've got a negative on the end. So that means both of our factors are one of our factors is going to be negative and one's going to be positive. So negative 1, positive 10, positive 1, negative 10, negative 2, positive 5, positive 2, negative 5. Which of those factors would add to give us a positive 3? Right there. So I'm just going to fill it in with my negative 2 and my positive 5. Once again, it doesn't matter if I wrote it like this. It's the same answer, so don't get hung up on the order there. All right, just a few extra examples to help you with the homework assignment. Right here, these are exactly what we just did, except they also have a GCF. Okay, they also have a GCF. So first going to factor out the GCF. And looking at the problem, they're all divisible by 2. So I'm going to go ahead and factor a 2 out. And if I divided every one of those terms by 2, I'd be left with x squared, I'd be left with 5x, and I'd be left with 4. Now I'm going to apply the rule I was just doing. What are the factors of 4? And notice they're all positive, so I'm looking for just all positive factors. 1 and 4 and 2 and 2. Which of those would add to give me this middle term of 5, 1, and 4? So my answer, I'm going to run out of room here, is 2 times the quantity x plus 1, x plus 4. Okay. Next, I see they're all divisible by 5, so I'm going to divide them all by 5. If I do so, the 5 is now on the outside, and I'm left with x squared minus 2x plus 1. Okay. And I'm looking for two numbers that will multiply to give me positive 1, but add to give me negative 2. There's only one option, negative 1 and negative 1. Okay, negative 1 times negative 1 is positive 1, but negative 1 plus negative 1 is negative 2. So the 5 is still on the outside because it was factored out. It's a factor of the problem, so it's still part of the problem. And then I had x minus 1 times x minus 1, and it's written out twice, so we can write it once and put a square after it. Okay, so now you guys are going to continue. You're going to list the factors out of your last term and find the pair that matches up to equal the middle term, and then write them out. Now, notice on the last two, my class yesterday that did this assignment kind of struggled. Notice on these last two that you're back to just some GCF problems, okay? So you're not trying to do this whole two numbers that multiply to equal the last term, add to equal the middle term. You're just doing GCF down here, okay? Like at the very beginning of the notes. All right, good luck. If you guys have any questions, please email me.